The Doppler effect is that thing you hear when an ambulance is around. It sounds different when it comes towards you than when it goes away. It's because the sound waves get compressed in the first case and stretched out in the second. Today we'll code a web app that shows the Doppler effect in action. It will be just HTML, CSS, and JavaScript. We'll control the car using the keyboard, and it's going to generate sound waves that will visualize like this, and they'll be received by a microphone. Now get your coding editors ready and make sure you watch till the end for the sonic boom. Get it? Because the Doppler effect is the reason. No.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Today we'll start with something from the self-driving car code base, so check the link in the description. And we'll use the version from the second lesson. You can find both lessons on YouTube if you're curious, but now we will use this code from here. And I already downloaded and added it to my Visual Studio Code here. And what it does, if you open this index.html, it looks like this. There is a car there. It just looks like a rectangle here. And you can move it with the arrow keys on your keyboard along this road. So I like to have this control when we study the Doppler effect. And we will build the sounds on top of this. The first thing we'll do is generate sound waves around the car. They will go like pulses in all directions. And going to index.html, we are going to copy one of these scripts and add here a sound wave.js. In Visual Studio Code, if you control-click on this, it's going to create a file for you. And in it, I'm going to use the same structure from the self-driving car code. So this is going to be a sound wave class. And the constructor, we need to specify where should this sound wave start. So X and Y. And let's set these parameters as attributes of the class, like so. Now the radius of the sound wave is going to be 0 in the beginning. And this is going to update. This is going to increase on each frame. I'm just going to give it an update method and say here that the radius increases by, let's say, 10. And let's give it a draw method given a canvas context. We will just draw a circle, so we begin a path. And let's make it clear by setting its stroke style to red. And I'm going to use the arc method at this location, so this X, this Y, and with the radius as well. And the last two parameters say that I want a full circle, so starting at 0 degrees and going all the way to 360 degrees. But it has to be specified in radians in JavaScript, so 360 degrees is 2 pi radians. And now we stroke. So we have this kind of blueprint now, and we can go to generate the sound waves. We'll do that in main.js. Maybe here at the top. We will have an array that holds many sound waves like this. It's going to be an empty array. But then we're going to have an interval with the callback function that pushes into this sound waves array a new sound wave at the car location. So car.x, car.y, and we do this every 1000 milliseconds, so once per second. Now we also have to tell these sound waves to update, and we can do that after the car updates its location. So let's loop through all of the sound waves, like so. And for each sound wave, we are going to tell it to update. And we also should draw them. I'm going to draw them after the car. So they will appear on top of the car, looping through all of the sound waves and telling them to draw themselves on the canvas. So this is what I meant by following the same structure of the self-driving car code. The same type of methods appear in both of these. Now let's save this and refresh the page. And you can see those pulses appearing there already. Nice. And they start always where the car is. So this works already. But we need to somehow pick up those sounds, figure out that we need to play a sound then. And we'll do that by implementing a kind of a microphone object that detects when the sound wave hits it. Let's go back to index.html and import a new file, microphone.js, and control click it to create a new class, microphone. And the constructor at x and y, we just give it the position the same way we did with the sound wave. And now the draw, I'm going to cheat here a little bit and just use an emoji. So let's begin path and fill text. And the text, I'm just going to copy here an emoji. You can get the link to it in the video description. It looks like a microphone. And we also have to say at this X and this Y. Now let's create a microphone in main.js. Maybe here at the top below the car. And the X, I will use the same X as the car, so the center lane of the road. And the Y, the car is already at 100, so down a little bit. And I want the microphone to be somewhere up so that we are heading towards it. Let's just try minus 400 here. And we need to draw this microphone. I'm going to draw it between the car and the road here so that it appears above the road but beneath the car. So microphone, draw CTX. And now if we save and refresh, we see something here. It's not yet the microphone. We need to add the UTF-8 encoding to the file, so we could do that by going here and adding a meta tag to support those symbols like this. And now if we refresh, it's looking good, but very, very small. So let's go back to microphone.js and set the font to 50 pixels, Arial. And actually it's not even centered because this center location is at its bottom left corner. So let's also fix that and align the text to center and give it the baseline of middle. And now if we refresh, the microphone is there. Let me just zoom out so that I see both things at the same time. Okay. Now we have to make the microphone receive these signals. So we should detect if the circles here, if the microphone is going inside the circle, basically. And that's easy to do. We just go here and after the sound waves update, we can tell the microphone to receive these sound waves, all of them, and handle them in some way. And this receive method we will have to implement in the microphone class and pass there the sound waves as the parameter. And we will loop through all of them one by one. And each sound wave, if the distance between that sound wave, its location, and this location is less than the sound wave radius, then we can ask the sound wave to play some noise. So let's do this. And we have to implement two things, a distance function and a play method for the sound wave. The distance function is easy, it's just Euclidean distance. And we will add it here in utils.js. In 2D here, it's just the result of applying the Pythagorean theorem once. I have video on both of those if interested. And the sound wave needs that play function. So we want to play a noise, and you could record some ambulance noises or maybe even find some online, but I like to generate them using the Web Audio API. So I'm just going to define here at the top a global variable and initialize it to the audio context and try supporting Safari as well. Now with this audio context, we can implement a play method where we play a kind of a beep noise to begin with, and we will give it a duration. Let's try to say that the beep is going to last maybe half a second for now. And to generate it, we create a simple oscillator like this. Connect it to the audio context destination. Start the oscillator and stop the oscillator after this duration. So adding to the current time the duration. And now something should work. If we save and refresh, you don't hear anything when the sound wave touches this, because if we open the developer tool, horrible! The audio context is not allowed to start unless you interact with the page. So I interacted with the page by opening the developer tools, and something horrible started. It's because after a sound wave goes beyond the microphone, on every frame the microphone is inside of that area and it's gonna play, but we don't want that. We want the play to happen just as the sound wave is passing the microphone. So it should really play only once. And we do that by adding here an attribute played, setting it to false, and then here on play we can check if it played already, then we can return, so we don't bother with this rest of the code. But if it didn't play, it goes here, and at the end we can also set that it did play. So once this play is executing these, it won't do it again for the same sound wave. Now let's save this and refresh. And it doesn't sound anything, but if we start to use the arrow keys, it's already sounding like something familiar. It's like phones in the past when you couldn't connect to somebody. I don't know if they still do it today though. And if you go backwards like this, the frequency is lower. And if you go forwards faster like this, listen. See? It's speeding up. Now it starts to be like those... and now it's slowing down again. It's kind of like the heart rate monitor systems that increase when you have a high pulse. You can already hear the Doppler effect. But I want to make this nicer. So let's make it sound like an ambulance and give it those kind of nee-no sounds. And back here in main.js, at the top, we can detect which sound it needs to play by using a variable like this, and then setting it to nee. And we have to pass it here to the constructor of the sound wave. and then change it from, if it's ni, let's change it to no, and otherwise back to ni. So it's gonna oscillate between those. Now, inside of sound wave, we have to accept the third parameter. And maybe here I'm going to set the frequency of the sound depending on ni, no. If it's ni, let's say 700, the higher frequency, and 500, the lower frequency. And let's also visualize this differently. So now we're using this red color here. Let's make the color, if it's ni, be red, but otherwise let's set it to blue. I think it's kind of like the Siren. And we use these values next. So after we create the oscillator, we set the value of the frequency to this frequency at the current time when the oscillator gets initialized, essentially. And the color, we can just replace here red with this color. And let's save and refresh. And now the sound waves are red and blue and red and blue. And let's see if they sound differently. I'm gonna move a little bit. Yeah, almost. We can do much better than that. I'm going to set the type of the oscillator to sawtooth for a better sound. And better means worse, because ambulances are supposed to sound annoying, so you know they're there. But this is what happens now. I want, when we go further away, to be less loud. So let's try to implement that as well. And add an envelope here so that we can control the gain. And that means here, when we connect to the destination, we actually, let me copy this line. We connect to the envelope instead. The oscillator goes to the envelope, and then the envelope connects to the destination. And this loudness, I'm gonna use a mathematical function for it. It's gonna be e to the power minus the radius, and this is gonna go like that, depending on the distance. But it's gonna go really fast to 0, so we have to use a fraction of the radius here to compensate for that. And you can play with these values, see if you want the ambulance to be heard from further away, then you can increase this and see how that goes. But now, with this new gain in place, let's start moving backwards now. Yeah, it's not very loud anymore. And if we go forward, okay, approaching ambulance. And you can hear this change there. That's the Doppler effect. I want to make each of the beeps a little bit softer, so they would start at 0 gain, quickly go up, and then flatten out linearly. And let's do that. I'm gonna set this initial loudness to 0. There's a kind of click in the beginning, and I don't like it. It's gonna remove the click. If we go to that loudness quickly, like after the current time plus, let's say, 1/10 of a second, and then go down back to 0 after the duration. So current time plus duration, like that. Let's save. And now it's better, but I think we can work with the higher duration, maybe 1 second. Yeah, nice. Okay, great. And of course, you could make the car look like an ambulance. Watch phase 1 of the course to see how I eventually make it look like a real car. And phase 2 teaches also about sounds. No, phase 3 teaches about sounds. And when making the racing game, we make the engine noise. That could be used here as well. Actually, you can play with other parameters as well, like the speed of the sound, or maybe nicer to work with the speed of the car. Like if you set the max speed to 10 and restart, let me go, wow, quite fast. Let me go down a bit to get some speed. And now we are generating a sonic boom. There it went. Okay, thanks for watching and see you guys.